So to continue that chapter, remember we will be elaborating little bit about length, mass and time. So we will start with units of length. Basically, remember, we will be considering the smaller units of length. Why smaller units of length? Because when we measure the larger units, that is the distance of sun to the earth, distance of two heavenly bodies, we measure light years. So big approximations are there. So for the smaller units are very important for physics and chemistry, because we have to measure the intermolecular space. We have to measure very small quantities like wavelength of light in measuring those lengths. So meters are not suitable. So we will find some smaller units related to meters like this. See here, first unit of length is angstrom. It is denoted by a degree, and it is 10 to the power minus 10 meters. Remember, the second one is 1 nanometer, that is represented by mm, and it is 10 to the power minus 9 meters. Then another unit will be there, that is called Fermi, F, denoted by F. It is 10 to the power much more smaller, 10 to the power minus 15 meters. Another unit will be there, that is called picometer, that is PM, that is 10 to the power minus 12 meters. Remember, so I am writing it. So 1 picometer, that is PM, is equals, remember this, 10 to the power minus 12 meter. It is used in farad, that means in capacity. You have not learned that. So wait for a few years, we will all deal with those things. And remember, from this chapter you can expect a 1 mark question, very short question, a fill in the blanks like this, that 1 angstrom equals to dash meter. So in the blank you have to write 10 to the power minus 9. In the last year board paper, that is the question paper which was applied from council, they have asked this type of 1 mark question. Say 1 Fermi equals to dash meter. So your answer will be 10 to the power minus 15 meters. Now, coming to the use of these smaller units. Remember, this is another 1 mark question, and we students have a bad habit of forgetting things in the exam hall. So don't worry, you have to remember this one. So these smaller units are used to measure, remember, the wavelength of light. You all know what is wavelength. So wavelength of lights are very short quantities, short physical quantities. So these smaller units of length used to measure the wavelength of light. Then it is used to measure the intermolecular space. You know the intermolecular space for solid is very less, and liquid it is a little bit higher, and the gas it is much more higher. So in order to measure the intermolecular space, that is very small space, we have to use these units. So these are few familiar units. See, I am teaching you in view of your exam point of view. So this thing you can expect as fill in the blanks, and this thing you can expect as 1 mark question, that is write the use of, say, angstrom, Fermi, these are. So other than this thing you have to learn, that is mean solar day. You know what is a solar day. 1 day is 24 hours and 1 hour is 60 minutes, 1 minute is 60 seconds. So if you multiply this becomes 86400, 86,400 seconds. So what is a mean solar day? That is 1 by 86400 meters per second is called mean solar day. So, and what is light year? The path which are covered by light in 1 year. We know the velocity of light is 3 into 10 to the power 8 meters per second. So with that velocity, the distance covered by light in 1 year is called light year. So you all know, you have learned this in the lower classes. After coming to the unit of length, we will be coming to the unit of mass. Remember, smaller unit of mass, and this is well accepted unit all over the world, that is called atomic mass unit. Remember, this is not only for physics, you have to learn this for chemistry also. So 1 atomic mass unit, remember, it is represented by AMU, or simply as U. when the mass of one atom of any element is compared with the mass of 1/12 of the mass of carbon atom, or 1/16 the mass of oxygen atom, or 1 divided by 35.5 mass of chlorine atom, then the physical quantity we will obtain is called atomic mass unit. And again I am repeating it, when the mass of an atom, any substance, is compared means ratio, that is 1/12 the mass of carbon atom. Why 1/12? 1/12 means the carbon has the atomic number of 12. And for oxygen, see, 1/16 the mass of oxygen, because oxygen has the atomic number of how much? 16. So here we are taking oxygen, carbon, chlorine, all are as standard values. Remember, such as 1 meter, 1 kg. Here also, in time of measuring the mass of another atom, another element, we are taking the scale or the standard as carbon, oxygen or chlorine. These are called scales. So in higher classes you got to learn it, or up to now, when the mass of an atom is compared with 1/12 the mass, see, 1/12 the mass of one carbon atom, or 1/16 of the mass of one oxygen atom, then it is known as one atomic mass unit, or simple as 1 U or 1 AMU. And lastly, I have told you about mean solar day. Mean solar day is what? The day is expressed in seconds. So 1 mean solar day. So 1 mean solar day. Remember this one, solar day is equals, so I'm sorry, this is not mean solar day, 1 second. Sorry. So I can write it like this: 1 second is equals 1/86400 of 1 mean solar day. Remember this, solar day. So for mean solar day, it is also one time it was there in your exam. That is, what is mean solar day? You have to convert the day into second, and 1 second. What is 1 second? That is the mean second is 1/86400 of 1 mean solar day.